Hi guys, this is part 1 of AP Calculus AB, Unit 8. For this one, we'll be finding the area between these two graphs using integration. So the graph is going to look like this, where you'll have y1 looking something like this, and y2, which will be coming through it, and looking something like that. So the way you're going to be able to find this area here is by taking the area under y2, which is this whole area, and then you will be subtracting this area, which will leave you with just the one that you want. So how would we do that? You're just going to take the integral of y2 and subtract it for y1 from the given area here and here. So that way it will give you the total area underneath. So for this problem, what we first need to do is find these values. And to do that, we set y1 equal to y2. So we'll start with x squared plus 2x plus 1 and set it equal to y2, which is 2x plus 5. Now we're going to solve for it. So we'll minus 2x minus 5, and I'll put it all on one side. These will cancel out, so it'll be plus. So plus 2x minus 2x plus 1 minus 5, and this will end up giving us 2x. These will cancel each other out, and you'll be left with 2x minus 4 equals 0. And now this is basic algebra from here. You just take this would end up being x minus 2, x plus 2, and then you know the zeros equal 2 and negative 2. Okay, so now that we found the 2 points, we will now set it up the integral. So you will have the integral of negative 2 to 2, and you will put in 2x plus 5 2x plus 5 minus x squared plus 2x plus 1. Okay, and then this will go to the integral of negative 2 to 2 of 2x plus 5 minus x squared minus 2x minus 1 when you distribute it, and that will eventually simplify to the integral of negative 2 to 2 of negative x squared plus 4. So now that we have just the integral of negative x squared plus 4, we will find the actual integral, which will end up being negative x cubed over 3 plus 4x. And we will evaluate that from negative 2 to 2. Okay, so now that you have the two numbers and you have the integral, you're going to just plug them in and solve. So the first one, you'll have negative 2 to the 3 over 3 plus 4 times 2. This will end up being negative 8 over 3 plus 8. 8 is equal to 24 over 3. 24 minus 8 is 16 over 3. Okay, so that's your first one. And you'll be subtracting this from negative of negative 2 cubed over 3 plus 4 times negative 2. This will be negative 8 times the negative will be 8 over 3 minus 8. This will equal negative, because it's the same thing as over here. So we'll have 24 over 3 minus, so 8 minus that would equal negative 16 over 3. You're going to subtract negative 16 over 3. We know that negatives become positives. 16 plus 16 equals 32 over 3. And that will be the area equals area between the two graphs. Okay, let's try a new problem. For this one, we have y equals e to the x, y equals x, and then we are bound at x equals 2. Okay, so first let's graph this so we can have a general idea of which one's going to be above and which one's going to be below. So e to the x roughly looks like this. And then we know when y equals x, it's just going to be a straight line through the middle. And then when x is equal to 2, that's just going to be roughly here. So x is equal to 2. So now we're trying to find this area in between here. So we know from the last problem that the way to do that is you take the area under this one, subtract this one, and then you'll be left with the difference in between. Okay, so first we need to set these equal to each other. So e to the x equals x. Take the natural log of both sides. We're left with x equals natural log x. And that's only equal to each other when x is equal to 0. Okay, so we know our values will be 0 and 2. The reason it's 2 is because that's where it's limited. So it would go on indefinitely, but we're limited to 2. Okay. Now we will solve from there. So we will need to take the integral from 0 to 2, and then we know it's e to the x minus x. Okay, and then after we set up from there, it'll end up being, we know e to the x is just e to the x. We know minus x will be negative x squared over 2, and we will evaluate that from 0 to 2. Now, the integral of 0 in this case will just be, well, we know e to the 0 will be 1, and we know this will be 0, so it'll just be minusing 1. Okay, now if we plug in 2, it'll be e squared minus 2 squared, which is 4, over 2, which is 2, so it's minus 2, minus 1. So that will leave us with the area equaling e squared minus 3. Now e squared is a constant, so it'll give us some long like decimal place number, but you can just leave it simplified as that. Okay, now let's go on to the next step, which is finding the average value. So the equation for average value is 1 over b minus a, the integral from a to b f of x dx. So for the first example we'll do is for the equation 3x squared minus 2x evaluated from 1 to 4, let's find the average. Okay, so first thing we do is set this up. It's 1, b will be this, a is this, b minus a is 4 minus 1 is 1/3 of the integral of f of x dx. So the integral of 3x squared minus 2x evaluated from 1 to 4. So we're just going to leave this part out and we'll add it back in at the end. So we'll just take on the integral. So the integral of this is going to be x cubed over 3 minus 2x squared over 2. These work out nicely where they cancel out. So you're left with x cubed minus x squared evaluated from 1 to 4. Okay, now you plug this in. 1's just going to end up being 1, 1, 1. So 1 minus 1 is 0. So that will be nothing. So now we just need to find the 4. 4 cubed is 16, or sorry, that's 4 squared, which is what you'll be minusing by. 4 cubed is going to be 64, minus 16 is 48. Okay, and then you're going to times that by 1/3. Like we said, we'll bring this all the way back over. And that will give us our answer of 16, which will be our area. Or sorry, not area, it'll be the average. Okay, so now let's try a little bit more of an advanced one. So for this one, we're given the integral from -2 to 4 of x squared plus 1 dx equals 30. And you're trying to find the average value of f on the interval that c would fit. So basically, you're just trying to find the c. Now, to solve this, what we're going to do is we're going to find the average value plus c and set it equal to 30. So how this works is it, just like in the last problem, 1 over b minus a, 4 minus -2 is, so you have 1/6 integral from -2 to 4 of x squared plus 1 dx. So now how you would solve that, you plug it in, so negative x squared, x cubed over 3 plus x evaluated from 4 and -2. So now you have -8 over 3 minus 2, which is going to equal, that's going to be 6 over 3 minus 8, 8 minus 6, or 8 plus 6 is going to be 14 over 3, is going to be your -2. So I'll plug that into here. And then if you plug in 4 cubed is 64 over 3, 64 plus 4, 64 over 3 plus 4, which is 12 over 3, will give you 76 over 3. So you have 76 over 3. So you have that minus -14 plus 3 equals, oh, my bad, plus 14 over 3, which gives you 90 over 3, which equals 30. Okay, so you have 90 over 3, which equals 30. And that gives us our integral for the area. So we know the average value is going to be 1/6 the integral, which is 30, which will give us 5. So 5 is our x value that we will be plugging in. Now to find the c, we need to go back to our original equation, which was x squared plus 1. Okay, and we plug in the x, or we use that value and set it equal to x. So we have c squared, I'm just plugging in a c because that's the way you do it, plus 1 equals 5, which we got from here. Okay, so now you're going to subtract the 1, c squared equals 4. Take the square root of both sides. C can equal plus or minus 2, which is what we're looking for. Therefore, these are the values that can satisfy c on our integral. So our integral will end up being x cubed over 3 plus x plus or minus 2, which will give us the value of 30 when we evaluate from -2 to 4. So your real answer is just x equals, or c equals, plus or minus 2. Okay, so for this last one, we'll be looking at a graph, and this will be our v of t graph. Okay, so what do we know? This is basically the graph of the derivative. And using basic fundamental theorem of calculus, v of t, so if we want to find the total area, it'll just be the integral of v of t. So the area is just this area underneath here. So more simply put, we just need to find the area under the graph, and we can do this by separating it into chunks. Chunks look like this, this, and this. So 1 times 2 will be 2. This area is 2 times 2 is 4. This is 1/2 of 2 times 2, which is 4 divided by 2, or 2. This will be a drop of 4 over 1. So 4 times 1 divided by 2, this will also be 2. Then now we're approaching into the negative category because it's below the x-axis. So this is over 1 down 2 divided by 2. This will be -1. This will be 2 times 2 is 4, so -4. And then this is the same thing again, -1. Okay, so now that you have all these bits, you can add them up. So when we're trying to find the objects at rest, which will be our first question, the object at rest is just when the x or the line goes through 0, which is these 2 points. So object is at rest at 4 and 8. Okay, so that's part A. Next, part B is evaluating from 1 to 6 of VT dt. Okay, so how would we do this? You're simply just going to take 1 to 6, this area right here, and add up all the numbers together. So you know it's 4 plus 2 plus 2, which is in the positive area, and then you're going to subtract it by 1 plus 4, but actually this is going to be here, so it's just 2. So now you have 8 minus 3, which will give you the area of 5. Okay. So now let's go on to C. And in this case, C is asking for the position at 5. 5 will just be you take it from 0 and you go to 5. So we know this total area up here is going to be 10, and then 5 is just -1, so we have 9. Okay, and now for C, which will be our last question of the day. C, we're going to try and find the total distance traveled over the whole thing. So distance traveled is basically the absolute value of these things, because you're not trying to find the position. The position will be minus plus, but traveled is just it went there, it went there, it went there, and you're trying to add these all up. Okay, so all you do is just take the top half, which is 10, plus the bottom half, or the absolute value of the bottom half, and the bottom half is -6, but we know the absolute value will be 6, so the total distance traveled is 16. Okay guys, if you like the video, I'll be making more of these. See you next time.